In this video, we're going to take a look at derivatives of trigonometric functions. In pre-calculus, you learned all about trigonometric functions. And just to repeat, the two main trigonometric functions where all the other ones are based off of are sine and cosine. So as you see here, we have sine and cosine, and then the derivative of sine is cosine, the derivative of cosine is negative sine. So if you can remember those two identities, just these two identities, then you have the rest of them. Because remember, all of the other ones are just different. For example, tangent is sine over cosine. All right, and then secant is 1 over cosine and so forth. Cotangent is just cosine over sine and so forth. So if you can remember what the derivative of sine is, what the derivative of cosine is, then you can remember the rest of them. Okay, or at least come up with the rest of them, figure out what they are. Anyway, so this is going to be our main focus for these notes, and there's only going to be one video, so there's not much to do other than maybe an example or two. And then also the third derivative, we've talked about the first derivative being the velocity, second derivative being the acceleration of an object, and then the third derivative, now just real quick, is what we call the jerk. Rarely will you see this, okay, on an AP exam or on a question, but just in case, I'm going to throw it in there so you know what it is. But the jerk is defined as how quickly acceleration changes. So if you're in a car and you accelerate extremely quickly, what's that do? It throws you back into your seat, so it jerks you back into your seat. And so if you decelerate, not negative acceleration, but decelerate really quickly, so you slam on the brakes, what's it do? It throws you forward or jerks you forward. It's a sudden change in acceleration. Just be familiar with that jerk is the third derivative of the position function, the second derivative of velocity, or the first derivative of acceleration. Okay, so let's take a look at an example here. Find the derivatives of these two functions. So first of all, you have x squared sine of x. All right, you notice that in this case, you are going to have to use the product rule. And that is because you have two functions being multiplied together. All right, so you have to use the sip and piss rule, whatever you want to call it, where your s is x squared, so s prime is 2x, and your p is sine of x. So this is where the new stuff for this set of notes comes in, finding the derivative of sine. So if you look back, the derivative of sine is just cosine. All right, so you can put those together. S times p prime plus s prime times p, and so you would have x squared, so dy dx is equal to x squared times the cosine of x plus 2x times the sine of x. Not much that you can do there. Let's just rewrite it maybe without some parentheses. So you would just have x squared cosine of x plus 2x sine of x. And then that would be as far as you could go. And so this would be our derivative of that original function. All right, so then on this one, on part B, you notice you have cosine divided by 1 minus sine of x. So here we would have to use the quotient rule. And remember, quotient rule is low d high minus high d low, all over low low. So if you want to go ahead and try this one on your own, you can. And then when you come back, check your answer. So try this one on your own and then come back and check your answer, see how you did. So if we take a look, just check your work, see how you did. Just a few things. So you do low d high, 1 minus sine of x is your low. Derivative of cosine, which is your high, is negative sine, minus high d low, the derivative of 1 minus sine of x is just negative cosine of x, because the derivative of 1 is 0, then the derivative of negative sine is negative cosine. And then over low, low, that's where the 1 minus sine of x quantity squared comes from. And then don't multiply this bottom part out, and I'll show you why. Hardly ever do you need to multiply that bottom out. But then you notice when you go ahead and simplify this, so you distribute this negative sign in, you would get negative sine times 1, which is negative sine, plus negative sine times negative sine, which is sine squared. And then also when you multiply these, you have negative cosine here times the negative cosine here, giving you positive cosine squared. All right, and then back from your days of pre-calculus, you should recognize this as a Pythagorean identity, and sine squared plus cosine squared is equal to 1. So that's where you get 1 minus sine of x down here. Now, if you think of the denominator as the quantity squared, so it's 1 minus sine of x times 1 minus sine of x, you would notice that this will simplify with one of those, reducing those to both 1s. So then you would just have 1 over 1 minus the sine of x, and then that is as simplified as this problem is going to get there. Okay, so let's go ahead and take a look at another example. So this problem says use s of t is equal to 2 minus sine of t to answer the following. All right, so we're finding the velocity, the speed, acceleration, and jerk. So jerk is just the derivative of acceleration. All right, and remember speed is just the absolute value of the velocity. That's all that is. So go ahead on your own, find these items, and then come back and check your work, see how you did. And looking at these problems, you notice the derivative of 2 minus 2 sine of t. So the derivative of 2 is 0, so this drops out. This drops out. And then derivative of negative 2 sine of t is negative 2 cosine of t. And then the absolute value of that is the speed. The acceleration then is the derivative of negative 2 cosine. So remember, this constant doesn't do anything. So it's just the derivative of cosine, which is the derivative of cosine. Yeah, the derivative of cosine is negative sine. And so actually this should be positive. There we go. Those should be positive. And then the derivative of sine is cosine, and so we have 2 cosine of t. All right. Now on the next one, now they want to find the velocity, speed, acceleration, and jerk at time pi over 4. So for example, we'll do this one together. Whoops. Instead of t, we know the time is at time equals pi over 4. So you would have negative 2 cosine of pi over 4. And if you remember, pi over 4 is radical 2 over 2. Cosine of pi over 4 is radical 2 over 2. So you'd have negative 2 times radical 2 over 2. And these 2's will simplify to 1, so you just have negative radical 2. And so that would be the velocity. And go ahead on your own, find the speed, acceleration, and jerk. And so looking at some of these, we did that one. Speed is just the absolute value, okay, of your velocity, which is negative square root of 2, which is square root of 2. Acceleration is 2 times the sine of pi over 4. Sine of pi over 4 is radical 2 over 2 as well. And so you simplify those 2's, you get radical 2. Same thing with the jerk, okay. Describe the motion of the body. So this is kind of where it can get tricky. So the motion is both where it's moving and how fast it's moving. Go ahead and try this on your own. Describe the motion of your body looking at the derivatives, the speeds, the acceleration, maybe even the jerk, doesn't matter, all at that time, and try to do your best to try to explain what's going on and when. Okay, so looking to see where for example, the slope or the velocity, where the velocity is 0, that's where it changes direction. And since this is a periodic function, we know it's going to change direction over and over. So this particle is just moving back and forth. So the motion of the body can be described easily just by telling us when it turns around and heads the other direction. All right, so looking at this, the velocity, negative 2 cosine of t is equal to 0. Okay, simplifying that, just cosine of t is equal to 0. Think about a unit circle. It's equal to 0 at pi over 2, 3 pi over 2, 5 pi over 2, and every 2k pi over 2 over that. Okay? And so that's where it's going to be equal to 0 at every point of there. That means it's going to be turning around. So you would describe this as the body changes direction. So you would write this down. Body changes direction every pi over 2 plus k pi. All right. It changes direction every pi after that. All right, so you would go through writing full sentences. I know I didn't write in full sentences here because it's kind of difficult to write on this thing, but write in full sentences your explanation. And then here I just have a couple other ones. The derivative of tangent is secant squared. Again, you can find all of these by just finding, for example, to find the derivative of tangent, you would just take the derivative of sine over cosine. So you'd have to use low d high minus high d low over low low. Okay, and you can check that if you don't believe me, but it'll get you secant squared, which is 1 over cosine squared. All right, because the low low, if you think about it, the low low part is cosine squared, and so the top will cancel out. Anyway, so the derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared, derivative of secant is secant tangent, derivative of cosecant is negative cosecant cotangent. All right. So first, let's go ahead and find the derivative and tangent and normal lines and their equations. So here you have f of x equals tan x over x at x equals 2. So this, we need this in order to find the equation of a tangent line. All right, and so we're going to go ahead and find the derivative. So here, the derivative is low d high, and you can go ahead and try this on your own. In fact, why don't you go ahead and try this on your own? I'll get you started. So it's low d high. The derivative tangent, if you look straight above, is secant squared, low d high, minus high d low. Derivative of x is just 1, all over, come on, Alright, so while I work this thing out, why don't you go ahead and try that on your own. Okay, so after we plug those in, now you can go ahead and, I'm going to change this, I know it might have messed everything up, but usually we're used to doing positive, so I'm just going to change this to x equals negative 2. So I'm going to go ahead and plug negative 2 in here. You notice the problem is you can't take the secant squared of negative 2, so what you have to do is use one of those properties and change it to 1 over cosine of negative 2 quantity squared. So you'd have negative 2 times that minus tangent of negative 2 all over 4. And you would get negative 3.4335. You might have a different answer if you use positive, which is fine. Now, this is the derivative or slope, okay, at x equals negative 2 in my case, possibly 2 for yours if you did positive 2, which is perfectly fine. So now we're going to go ahead and find the tangent. The tangent line, so that's going to be y is equal to your slope, which is negative 3.4335 times x minus x, so that's plus 2, plus your y value. Now your y value, you have to plug negative 2 in there, and I got 1.093, so it's going to be plus 1.093. And then your normal, alright, your normal is going to be the exact same thing, only this is reciprocated and it's the opposite. So it's going to be 1 over positive 3.4335. And then the rest is going to be the same. Okay, so you would have your tangent here And then the normal line is just the perpendicular, remember, and so all you do is change the slope. The rest is the same. It wants to go through the same point, so we keep the point the same. Okay, that's it for these notes. So remember, I know there's not many examples here, but the main idea was being able to use these identities here.